Hi students, let us now try to solve question number 13 of module 7 oscillation chapter. Two masses m1 m2 are suspended together by a massless spring of spring constant k. So this is spring of spring constant k and masses m1 m2 are suspended like this. When the masses are in equilibrium, m1 is removed without disturbing the system. So probably this should be m1 in that case. So this m1 is, when this is in equilibrium, m1 is removed from this system. Then statement 1 says angular frequency of m2. Then once you remove this m2 will go up and therefore you start oscillating. So angular frequency they are asking. It's a direct, right? Angular frequency root over k by m. Which m? That m which is oscillating. Once you remove m1, who will oscillate? m2, so it will be m2. They have given root over k by m1. So statement 1 is wrong. Statement 1 is wrong. This is right, but whatever they have given is wrong. Statement 2 is what? Amplitude of oscillation of M2. So once you remove M1, M2 will oscillate. That amplitude they are saying is M2G by K. So let us check whether this is right or wrong. So initially, when the two masses are in equilibrium, so let us say this was the natural length of the string. Meaning, when no blocks are connected, this is the length of the string. Once you connect these two blocks, it will come down. And then as it keeps oscillating, and then if there is a resistance and all, finally it will settle in the equilibrium position. So what would be the extension that time? So the extension, let us call this x1. How to find that extension? Well, it is in equilibrium, so net force on this should be 0. Downward force is how much? m1 plus m2g. That is balanced by which force? Spring force. Spring force will be how much? kx1. So that means x1 is m1 plus m2g by k. Right? Okay. Now, once you remove m1, then m2 will oscillate. Let us see where is the equilibrium position of m2. Let us say this is the equilibrium position of m2. So let's say this is the natural length like before, and therefore the extension now is, let's say, x2 from the natural length. So what will be the x2? Similarly, this way we can find now m2g is balanced by kx2, so it will be m2g by k. Now what do you mean by amplitude? Amplitude is from not the natural length, from its equilibrium position to its extreme position, right? So m2 was initially here, right? Was sitting here around say, right? Now once you remove m1, m2 starts to move up with zero speed, starts going up like this, and it oscillates. And we have found that this is the equilibrium position, right? This one, when m2 is there, and we know it can't go beyond this, because without disturbing the system we have allowed m2 to oscillate. It's not like we have kicked it or something, right? So if we leave it simply, then this remaining mass m2 will start to move from here itself. So therefore this would be the extreme position for m2, and we know this is the equilibrium position. So this must be the amplitude of mass m2. Understood? So what would be that amplitude? You can clearly see from the diagram. This is x1, this is x2. So amplitude will be x1 minus x2. And x1 is m1 plus m2 g by k. When you subtract from this, m2 and m2 will cancel, so you get m1 g by k. And I think they had mentioned this itself, right? So they had mentioned here m2 g by k. So that means even the given statement is wrong. So both the statements are wrong. Here we don't see any option matching. Okay, so probably some printing mistake has happened. What you can do is statement 2 you can put here as m2. Okay, so just change this m1 into m2 in the book. Then statement 1 would be false and statement 2 would be true. So the right answer would be option D. Okay, let's see question number 14. 14 is again a good question. It is based on damping. So you know that when a body oscillates, okay, there will be a restoring force which brings the body back to its mean position. Right? Without restoring force, a body will never oscillate. However, if there are no frictional forces or viscous forces, then the oscillations are called free oscillations. However, there will always be, in real life, always be some damping forces present. So in that case, what will happen is the amplitude of the body will not be constant. Why is it so? Because if there is friction, then you know that as it keeps moving in a frictionless medium, some of its mechanical energy will go to heat energy. Right? Friction always causes heat. So as that will happen, energy will decrease. Mechanical energy. Now what is formula for mechanical energy? Half m omega square a square. So as energy will decrease, amplitude will decrease. So amplitude at any given time t is equals to initial amplitude e power minus bt by 2. So this b is called the damping coefficient. Damping coefficient. It comes in which formula? So as the particle is moving in some viscous medium, there will be a frictional force which is taken to be proportional to velocity, and the constant that we write is damping coefficient. And minus sign would just mean that the frictional force will be opposite to the motion, which means opposite to the velocity. So this is like your Stokes law, right? 6 pi eta r v we used to write. So this is basically your damping constant. Okay. So here the question is saying that to find the damping coefficient, and they have given the time taken. So it says that a 50-gram object, so mass of the body is 50 gram, which means if you divide by 1000 is 0.05 kilograms. Moves on end of a spring with force constant 25 Newton per meter. Its initial displacement is 0.3 meter, initial displacement. So that would be your amplitude, right? So initial amplitude is 0.3 meter. A damping force F equals to minus BV, which I was mentioning before, acts on the object and the amplitude of the motion decreases to 0.1. So after some time, amplitude becomes 0.1 meter. In what time they have mentioned? 5 seconds. What would be the magnitude of the damping coefficient? So this is directly based on that formula. So A equals A naught e power minus Vt by 2m. So you should be just good in dealing with exponential functions. So A is 0.1, this is 0.3, e power minus b, time taken is 5 seconds, to mass. Mass is, we will substitute mass at the end, okay? So this will be point, and point you can imagine is removed, so this will be 1 by 3. So 1 by 3 will be equal to this, okay? So let us make this minus plus by taking 3 up. So 3 will be e power b into 5 by 2m. Then log 3 base e will be b into 5 by 2m. So from here, b will be how much? 2m into log 3 base e, which is mentioned in the question itself, 1.1 divided by 5. Mass of the body was 0.05. So if you multiply by 2, you get 0.1 into 1.1 divided by. Okay, let us not divide by, not multiply, okay, because 5 is mentioned in the denominator. So mass is 0.05 into 1.1 divided by 5. So this will give you 0.01. So this will be 2.2 into 0.01. So that will be, the answer will be 2.2 means 22, and then after 0.3 digits are there, so 0, 1, 0. What would be the unit? That's interesting. Okay, so what would be the unit of b? You know that exponential functions are dimensionless. So this is second, this is kg. So b must be kg per second, so that you can cancel the dimension of t by m. So it should be kg per second. Okay.